Thank you, Ray. Good morning, everyone. Really glad to be here. So SDN, by all accounts, is the next big thing in networking. And SD-WAN, its application, is experiencing the greatest growth. It's seeing the greatest interest, and unfortunately, the greatest hype. It's indeed the hype, the SD-WAN whitewashing that's going on in the industry that's creating a big issue for enterprises who want to extract and really understand the signal, what the value out of SD-WAN is from the noise that's in the market. So why is so much noise? Well, it's understandable. Almost every analyst is projecting very big market for SD-WAN. There is indeed a market for SD-WAN. And everyone who has been participating, every solution that has been participating in SD-WAN, or in the wide area network, I should say, wants to partake. As a result, what you see in the market is that rigid proprietary branch router that has been there forever at the edge of the wide area network is now labeled as SD-WAN. Or the WAN optimization platform, an appliance, or the IDS, IPS platform, or the appliance, everything is labeled SD-WAN. That creates a lot of confusion in the market. Well, fortunately, the requirements of enterprises have evolved since the first definition of SD-WAN came about. And that's what I want to talk about. I want to talk about what SD-WAN really should be, because that's what the title conveys, that the evolution of the requirements of enterprises are such that the original definition of SD-WAN doesn't quite meet those requirements. With Nuage Networks, we've been leading the charge in SDN from the beginning. We are part of Nokia, and we have created a network virtualization and automation platform that's now deployed worldwide. We have a lot of service providers, over 70 service providers that are deploying with our technology and offering managed SD-WAN services. We have over 60 to 70 channel partners, and together we are collaborating with the service providers and the channel partners to have managed service or managed SD-WAN service offering to the enterprises. So let me talk about what we are seeing as the evolved requirements of SD-WAN, and then I have some use cases also that I want to show of the real live deployments that are underway. So this is how we started the journey of SD-WAN. SD-WAN started because IPVPN was rather rigid, and it was offered only on a private IP network or private IP MPLS network. So SD-WAN 1.0 came along, and the whole idea of SD-WAN 1.0 was to make it time independent, to make it transport, location, and device independent, to use not only the private network, but also use the internet to provide that service overlay, a multi-tenanted service overlay, and have the cloud management to bring branches quickly and have that flexibility. Well, since that time, the requirements of enterprises have quite evolved, and now what enterprises, CIO, and CISOs worry about is, what's my multi-cloud strategy? Because I have assets and I have applications in the public cloud, in the SaaS, and I need to get to these cloud with a consistent governance and consistent policy. What is my value-add services strategy? In other words, I have, over time, number of appliances, and it's a sprawl of appliances in every branch, whether it's something as mundane as a print server or file sharing server, as well as the branch router, as well as the firewall, as well as a WAN appliance. How do I reduce the appliance and really take advantage of the SDN construct of VNFs in each of the branches? And finally, what's my end-to-end security policy? And this is rather important, and I'll touch on this in a great detail, but let's dive in and talk about each one of these. So specifically about multi-cloud strategy, it's about having enterprises really want a single pane of glass to provide and be able to do network governance across their VPNs, their VNFs, and their public cloud connectivity, whether it's SaaS, public cloud itself. And of course, they want to move workloads around. Over time, they want to do that, but they know that once they refactor a workload to work in AWS, they're stuck there forever. How do they allow that workload to move easily? How do you reduce the friction? How can I have a fully redundant network connectivity and that's resilient across MPLS and multiple internet ISP links? So let's start and dive into how we create the service overlay. So this was what SD-WAN 1.0 allowed us to do. It allowed us to use the MPLS underlay, use multiple ISP connectivity, including LTE, and with some cloud management, and if you're lucky with some declarative policy engine, be able to create those service overlays. But the question is that enough? Does that answer the multi-cloud strategy? Because the whole idea is to connect that service overlay seamlessly all the way to where the applications are, which are in the service provider cloud. And those applications could be a firewall appliance, a VNF. As Ray very succinctly and very well pointed out, a VNF is not SD-WAN, but VNF is very much part of that SD-WAN solution through a service chain. And that service chain happens in the NFV cloud. But how do you not break the automation? How do you extend the service overlay all the way to where the application endpoint is in the NFV cloud? And it has to be independent of the hypervisor technology or the type of the workload it is, whether it's a containerized workload or a virtual machine. So what you have is the ability that we are providing to our customers to have a bridge construct, if you will. A bridge router construct, it's a software construct that allows for those overlays to be extended seamlessly using the same policy and analytics engine and using the same controller all the way to that application endpoint, keeping that automation very, very consistent across and giving that single pane of glass. So this is great. A single API, single overlay network, fully multi-tenanted, all the way to the application. The question is, does this actually solve the entire puzzle? No, it doesn't, because what about the challenge with the public cloud connectivity? When you look at public cloud, you have AWS. Let's take AWS as an example. You have VPCs. Almost every enterprise have multiple VPCs. AWS says you must have multiple availability zones. Rightfully so. The question then is, for enterprises, to really dig and understand all the VPN connectivity constructs that AWS provides, understand all the APIs, create those VPNs in each of the availability zones, and then having done that, they have to do the orchestration again, understanding all of the APIs and the constructs of AWS. This is straight from AWS, by the way. So they have to do that. Once they've done that, they're fully locked in. There's so much friction that's created once you have done this exercise. And so that's not all. Enterprises, what they care about is when they have users that are in the branches that want to get to those applications in the public cloud, how do they do that? So if you look at the whole picture, now you have multiple underlays, branches connected to the multiple underlays, and you need to have a service overlay that extends not only to the NFV cloud, but also extends seamlessly to the public cloud, wherever it might be. What we provide here in this particular case is the ability to have a virtual gateway that front ends that VPC in AWS. When you do that, a VPC looks like any regular branch. And you can take and use the constructs of networking, you can use the constructs of MPBGP, something that we have done as an industry forever, and provide that resiliency, provide the ability to really have a single pane of glass, but have a very consistent, open protocols that we have used forever to do networking. As a result, the enterprise is not relying anymore on how do I use the APIs, how do I understand the APIs of AWS, how do I do that redundancy with AWS APIs. You don't need to do that anymore. Because now you're doing and using the regular constructs, and again, a single API that orchestrates this fully multi-tenanted service overlays end-to-end and allows for the enterprises then to have that governance, to have that compliance. Telefonica is a great example of one of our customers that is using our technology to provide managed SD-WAN services. They started by using us in the data center because they have a thriving data center managed data center practice. And then they extended this to what they're calling as their offer, a FlexWAN offer, which is based on SD-WAN from Nuage. They also intend to provide their customers those on-ramps to AWS, either through cloud exchanges like Equinix or directly as an overlay into AWS or Azure. Let's look at the next one, the value-added services. So value-added services, again, that branch sprawl, and how do you take advantage of the constructs of SDN, have that automation in place, have a streamlined methodology and strategy to really connect those appliances at will for branches that need them. What we have is a strategy that says it needs to be a flexible model because every branch will have different requirements. So we provide embedded functionality in terms of the URL filtering, all the NAT services, stateful firewall and ACLs. But then we also provide what we call as branch in a box, which provides the ability to host VNFs in a virtual CPE platform or a universal CPE platform. It does this very efficiently using the Mano architecture, but not the heavy-duty Mano orchestration, because you need really a lightweight VNFM and Vim function to be able to deploy these VNFs on that universal CPE. And that's what we do. And then, of course, the flexibility of service chaining it to any cloud, whether it's a telco cloud or in AWS. So the way it looks like is what you have is the ability to not only host and use embedded functionality in the branch, but then when a VNF is required in the branch to be able to very seamlessly, as Ray pointed out, have the VNF in the branch on top of the SD-WAN platform, not the other way around. It's not the appliance that's doing the primary function of firewall or WAN optimization and then, as an afterthought, doing SD-WAN. So that's what a real SD-WAN functionality looks like, and the ability to service chain it in the central office or in the telco cloud through a single API, again, and a single SDN controller. BT is another customer that's using Nuage to offer SD-WAN services. They call them Agile Connect. They have launched in 160 countries. And they are using exactly this strategy of having not only the connectivity of the branches, but being able to offer their customers those capabilities, those upselling capabilities, wherever they need them, in a very flexible, automated way through a self-service portal. Here's another customer, which is very interesting. This customer is using AWS to provide SD-WAN services. And they are doing it, it's a cloud-based offer, and they are doing it by offering the firewall VNFs and service chaining to the firewall VNFs that are hosted in AWS. And so it just shows you the flexibility that they are able to offer, and as a result, cover different geos very, very easily. Finally, the end-to-end security. So whenever there's a discussion on security in the context of a VPN, it naturally gravitates towards a perimeter-based classical firewall. And with VNFs, now it's about that particular VNF in the branch. But the fact is, the way the enterprise is and the way the threat surface is increased, where branches are everywhere and enterprises are accessing applications in all different clouds, it's not that classical firewall that's sufficient. You need that for sure. But you need the ability to do end-to-end microsegmentation because the threat surface and the landscape is so different. So how do you, and how, this is what the enterprises, CISOs are grappling with. How do I do that in a way where I can, first and foremost, have better protection, but I know that someone somehow will get in. So when they do get in, I need the ability to detect quickly and then respond in a fully automated fashion. And how do I use the SDN and SD-WAN construct to be able to do exactly that? So it's about using cloud-based analytics, visibility and security, because the ability for a good SD-WAN platform is very much there to provide that flow information, provide that application information. Because there's DPI engine running in the branch, there's a DPI all the way in the cloud as well, depending upon how that SD-WAN framework and platform is. It's about doing it across the board and then doing that end-to-end segmentation, which I'll show you in just a couple of minutes, and also then being able to do dynamically that feedback and automation to take an action. So how does that actually look like? First, using the cloud-based, fully hosted big data analytics, where everything is collected, enterprises are able to see who is talking to who, fully based on applications. And then, based on that, they can see whether everything that they're seeing is compliant or not. They're able to push a button. All those flows are then automatically converted to whitelist policies that are deployed across the entire domain, enterprise domain, and everything else is blacklisted. And then it's about dynamic security automation. So how does that work? First, let's look at what the problem is. The problem is this. In a VPN, once you get into the VPN, there is no microsegmentation. So the entire thing is a VPN. So if one branch gets infected, or if a workload in any data center gets infected, it can laterally spread very, very quickly. And there's several use cases, and painful ones, of enterprises that have experienced this and lost millions and millions of dollars as a result. So the reason is because once you get in, you can laterally move everywhere. So the actual microsegmentation is not just about microsegmentation, east-west microsegmentation in the data center. It has to include the branch. It must include the branch. So the end-to-end microsegmentation should look like this, where the partner is allowed access to certain applications, and only that is a single microsegment within that VPN. So within a VPN, there's another level of multi-tenancy, another level of granularity that allows for that end-to-end microsegmentation. Sales, anywhere in any branches, are only able to connect to sales applications, wherever they might be, in the private cloud or public cloud. Likewise, finance can only access finance applications. So in that case, when something is compromised, it's limited to that microsegment. It doesn't infect anything else. And in fact, through automation, and through SDN analytics, you can actually have the ability to dynamically then service chain that traffic to a honeypot or a heavy-duty firewall. That is what enterprises care about. So it's not just that classical perimeter-based firewall in the data center, at the HQ, in the DMZ, or now as a VNF in the branch. That's not sufficient to take really the advantage of the SDN construct and have that security end-to-end and make it dynamic is super, super important. Here's an example of big retailer that has deployed us, and they first deployed us in the data center, and they are using this end-to-end microsegmentation capability to include the branch and have within a VPN multiple levels of microsegments based on the users and their affinity to the applications that they get to. So this is the evolved SD-WAN. It's not the SD-WAN 1.0 that focused on just connecting branches. But SD-WAN 2.0 is about IT services, not IP services over an IP network. It's about providing IT services. It's about making sure that end-to-end, you're connecting users, wherever they are, to applications that might be in any cloud. And that is what we call as SD-WAN 2.0. Thank you very much.
Thank you, Sunil.